Hello friends, in this video I will explain to you how to use the Flask-SQLAlchemy extension in our Flask application. Most of the programming languages, especially the ones that are very popular like Java or even Python or .NET languages, etc., they are object oriented in nature. Whereas the database softwares that you use as a backend to the programs or applications written in these languages are, the data is stored in the tables and the tables are sort of flat files. So on one hand, the programming language has class or it is object oriented, and the database servers, the data is stored in the form of tables which are nothing but flat files. So the object relation mapping technique is used to map the object parameters of a class to the underlying RDBMS table structure. So what you have to do, at the end of the day, the table has the fields which are nothing but the instance which are equivalent to the instance variables of a class. So therefore, to map or to correlate the instance variables of a class to the fields in a table, that is how the object relation mapping is done. So it is a technique of mapping the object parameters to the table structure. In order to do that, any ORM API, object relation mapping API, provides the methods to perform the CRUD operation. CRUD operations are done on any database table. So those database applications or operations like insert, delete, update, select, etc., these operations, rather than doing through a raw SQL query or SQL command, insert into, update, set equal to, insert from, select star, etc., all these SQL statements, instead of the programmer or the developer being required to execute these raw SQL statements, he can now use his object oriented programming knowledge to perform all these activities using the ORM API. SQL Alchemy is a very popular toolkit for object relation mapping for Python related projects or programs. So it is a object relational mapper that presents all the mechanism for Python related database handling. SQL Alchemy can be used along with different database servers, like it can be used with Oracle, MySQL, SQLite, etc. Flask-SQLAlchemy is what? It is an extension to the, you can add it to the Flask setup or environment, which adds the SQL Alchemy support to your Flask application. So this is what is an object relation mapping, and the use of Flask-SQLAlchemy will enable ORM into your Flask application. So obviously you will have to install the extension by using the pip utility. Pip install Flask-SQLAlchemy will install it. In order to use the facilities, you have to import the SQL Alchemy class from this module. Statement is, from Flask-SQLAlchemy import SQL Alchemy. That is the mandatory step that you must do. Then in the application object, configuration of the application object of your Flask application, if the name of the object is app.config, specify the database URI, SQL Alchemy database URI is equal to which database you are going to use, SQLite students.SQLite3, if the students is the name of the SQLite database that you are going to use. Now object of this SQL Alchemy class, which you have imported, it will have all the helper functions for performing the ORM operations. It also provides what? the SQL Alchemy class, it also provides a model class which should be used as the parent for defining the model of or corresponding to each table in your database. So, in order to handle or process the data in the tables, you have to define an equivalent class based upon the model class which refers to or which is corresponding to the table in your SQLite database. Each model class corresponds to the table in the database. So, for example, if in the students database students.SQLite3 there is a students table, what you will have to do? You will have to define a class called as student which will be based upon the db.model. There you see, first create an object of SQL Alchemy class. It requires the Flask application object as the parameter. The db is the name of the SQL Alchemy class. Using the db.model as the parent, define the class students. The students is the name of the table in our database. Then you define all the corresponding fields or the instance variables corresponding to the fields in our table. So, db.column name, city, address, pin code. Additionally, I have defined a primary key also. So, id is equal to db.column. Student's id is the name of the field which is the primary key. It will be an integer. So, db.string is used as the data type for all these fields. As you can expect, name, city, address, pin code all will be strings. So this is the declaration of the table structure. Each instance variable corresponding to the field in your table. Okay. Now, if you create the object of the students class, obviously what is going to happen? Its constructor will execute. The name of the constructor is init. The constructor will provide 4 parameters: name, city, address, pin. Those 4 parameters will be used to initialize these 4 instance variables: name, self.name, self.city, address and pin code. So this will be initialized, the object will be created. When the object will be created, that object will be used for further processing. Now that the model is declared, now first the table, the database is in place, the table is there, the model is created, all these database related activity to create or use the database mentioned in the URI and create the tables, execute the create all function. So db.createAll will, if the database and the table are not present, they will be created, and if they are present, they will be used. It is equivalent to use a particular database kind of statement in our SQLite or any SQL related database. To this db object, there is a session object, db.session. So this session is a ORM's handle to the database. All the activities like insert the record, delete a record, update a record, etc., they have to be done with the help of this session. Session objects methods. One is session.add. What is to be added? If the object of the students class is created, the model class is created, the object will be used as an argument to this add function. So db.session.add, the name of the object of the model class, inserts a record into the mapped table, because your model is now mapping the table in your database. So therefore this add ultimately will add a record into the table. Okay. Similarly, db.session.delete, the name of the object model. What happens? The mapped table, from the mapped table, this particular object, or that means this particular row, will be deleted from the table. Now, in order to emulate the select query, you have to say model.query.all, in our case students. Students is the name of the model. model.query.all will be equivalent to the select star from students. So it will retrieve all the records from the underlying table. In this case, the underlying table is students. So it is equivalent to select star from students. Okay. If you want to apply, remember in the select query there is a where clause. Select star from students where marks are greater than something. So if you want to apply a filter, you can use the filter option. Model.query.filter, whichever the condition you want to. You can apply a filter to the retrieved record. That many number of records will be retrieved. Students.query.filter by, this is the condition, .all. So what happens? From the records that are retrieved, only those records in which city is equal to Hyderabad will be selected. Okay. Now, this is a form in which there is a provision to enter the data into 4 text fields. For example, name is having a text field, then email is having a text field, city, pin code, etc. And then there is a submit button, right? This is a simple HTML form, nothing else. And then the submit button will take the data back to the request path from which the request was generated. Okay. So when the request is, when for the first time when the form will be opened, that will be a get method. When it will be posted, the URL will be visited with the help of the post method, in which case all the data posted by this form will be extracted by request.form. So collect all that data, request.form, name, city, pin code and address. Use that data as the argument for the object of the students class. Student is equal to students, give 4 parameters. The object will be created. Use that object to add the record into the underlying table. So you say db.session.add student. The data will be added, and then finalize or commit the transaction by saying db.session.commit. So this is all the activity related or required to perform the insert operation, equivalent insert operation. SQL has an insert query, so the corresponding operation in a ORM mapper is like this, right? And if you want to perform the select operation, then for that purpose a show all view function has been defined, which will render a show all template. And what it will do? It will send the parameter as students equal to students.query.all. We have seen that model.query.all will retrieve all the records. Those records will be stored in a students parameter. Essentially this is a dictionary object. So from that dictionary object, on each row perform this, it will render a table. So at the end of the activity you will find a table being rendered on the browser with names of the fields and the values being displayed in a tabular form. So this is the entire sequence of events that is present in this entire activity. There will be a form, the form will be posted to a view function, the view function will fetch the data and perform the add or insert operation. On the other hand, there will be a equivalent select operation which will fire this query students.query.all, send the data to the template, and this Jinja2 template code will render a table onto the surface of the browser. So all these activities now I will show you one by one with the help of an example that will cover all these Flask-SQL Alchemy features and functionality. So with the help of this example we shall find out how to use the Flask-SQL Alchemy extension. along with the Flask application to manipulate or use a SQLite database. So first and foremost, you have to ensure that this extension Flask SQL Alchemy is installed in the working environment of our Flask application. So this is the virtual environment in which your Flask is installed. So now you try to install the Flask SQL Alchemy using the pip utility. So I will say name of the extension is Flask SQL Alchemy. It says requirement is already satisfied. That means what? This extension is already present. You can also verify this by starting a Python interpreter and you try to import that. So I will start the interpreter and write import statement. If this instruction is accepted, then it means that it is installed, otherwise not. There you see the module or the package is already present. Okay, so that is our first requirement fulfilled. Next we have a look at the Python code which performs all the operations on the underlying SQL database using this Flask SQL Alchemy extension. So these are our regular imports. For this particular exercise, you want to import this SQL Alchemy class from this Flask SQL Alchemy extension. So these are all the imports. Then of course this is the Flask application object. These two lines are the configuration of your app object, app.config SQL Alchemy database URI. That means what? You have to give the path to the database that you are going to use. The name of the database is students.sqlite3. The protocol that you are going to use is SQLite colon students.sqlite3, and then you have to set the secret key of your application by saying app.config secret key is equal to this. Okay, so this is again the configuration of your application object. Second step is to, rather the third step is to declare an object of the SQL Alchemy class which you have imported. It requires this app as the argument. So that SQL Alchemy class object I call it as DB. Now in this DB there is a db.model. Now this db.model is to be used as a base class for declaring a mapper class called as students, which means that this inside this students database there will be a table called as students, and this object of the students class will be each row in the table. So naturally what you have to do, you have to give the structure of that table. Now this DB object has a method or function called as db.column, which requires the arguments as the data type and the size. In the first place, the name of the field will be student ID. Its data type will be integer, and it is to be set as the primary key is equal to true. So this is the first field. Second field is name, db.column. It will be a string containing a string data up to 100 characters. City, db.column, again it will be a string with 50 characters. Address up to 200 characters string. Pin up to 10 characters string. So this is nothing but the structure of your table. Okay. Now every time when you declare an object of the students class, you know that whenever the object of a class is declared, the constructor goes to work and the constructor is in it. This constructor will be provided 4 arguments, each corresponding to the fields name, city, address, pin. So using these arguments, the object will be initialized. So later on, there will be an object of the students class declared, which will take 4 arguments. Okay, so this is our model. So 3 aspects we have seen: import, Flask application model, configuration, and declaration of the model. So this is our first step of the Python code. In this Flask application, 2 URL rules are defined. One is the slash and the other is slash new. I will explain this slash new first and then we will go to the slash. Slash new is mapped to a view function called as new. Now this URL may be called, or the application may reach this URL slash new in 2 ways. One is if the user directly enters into his browser's address bar localhost 5000 slash new. In that case, the method by which this URL is reached or fired will not be post, but it will be get. So therefore what will happen? This block will not be executed. This statement will be executed. And what it is doing? It is rendering a new.html template on the browser. Okay, so we will have to see what is there in new.html. So this is the new.html, in which this is a form, and in the form there are 4 text elements, one each for name, city, address, and pin code, isn't it? And then there is a submit button. When the user clicks, after filling the form, when the user clicks the submit button, it will be posted to the same URL by the method post. So what happens when the form is posted, or rather what happens when this new URL is reached with the post method? So let us go back. So in this case, now when again this slash new URL is fired, now the method is post, so therefore this block of statements will be executed, isn't it? So if the method is post, but the form that has been posted containing 4 form elements, name, city, address, and pin code, any of those fields are empty, then obviously that data should not be added. So therefore what is to be done? A message is to be flashed, an error message, please enter all the field names, and this flash function will generate a flash message which will be displayed on the browser when the next URL is accessed. Okay, but if this form is properly filled, all the fields do have a certain value, then the else block will be executed. Here the object of the students class is created with 4 attributes or 4 parameters extracted from the request.form object. Request.form name, city, address, pin code, these will be the values that will be corresponding to the HTML form data. Using or taking these values, this student object is created. Now this student object is to be added into the database that is right now in the session. So db.session.add, add what? The student object. If it is properly executed, commit the operations by saying db.session.commit, and then the message to be flashed, record the message to be flashed as record was successfully added. So, either this message will has to be flashed or this has to be flashed, where when when your browser is redirected towards another URL, show all. Okay, so this is the activity which is done when the user clicks on the link which takes it to this insertion of new record activities done. Incidentally, what happens to the flash messages? If the record, if the data is not properly filled, that means if this condition is true, when it will be true, either name or city or address etc. will not be entered, then this is the message to be flashed. As you know, the flash will be the message will be flashed when the next URL or next view function is executed. So, after this flash, what is going to happen? This is not going to take place, the else block. So, the control of the program will come to this. So, in the new.html, if the form is improperly filled, the form must be shown again, but with an error message flashed. So, if you remember, if you will have a look at the new.html again. So, this is the template Jinja 2 template code which will take care of the messages to be flashed. Extract the messages by using the get flashed messages function and display take out each function at a time and display. There will be only one, indicating that there is some error in the form entry, right. So, this is the explanation for this part of your new.html. So, that takes us to this else block. What happens in the else block? When the data is properly filled up, what is going to happen? This object will be created and the record will be added, and the browser will be redirected towards the show all. Show all, the URL for show all function. What is the URL for show all function? This is the URL for show all function. It is going to render the show all.html, and it is going to take an attribute which is a result of this query, students.query.all. All the records in the students table will form a record set object which will be a value of this students attribute. Okay, so either by directly entering slash into the browser localhost 5000 slash, this show all HTML will be rendered, or after completing or after performing the insert operation, after adding the record, again this show all URL, which is again show all.html, will be displayed. So, what is there in show all.html? This is the HTML code for show all.html. At the top there is again a template code which will rather this much. If at all there are any messages, and there will be, this message will be flashed when this show all.html is going to be rendered after the successful completion of the insert operation. What is that? The record was successfully added. That will be displayed by this. Okay. Now, the rest of the HTML code is displaying a table. This is the table, out of which the first row is the heading, name, address, city, pin code. This will be appearing as in the first row in the as if they are the field names or the titles of the table. And you know that the show all.html is going to be rendered with one parameter which is the record set or result set of the query all function, student dot query all function. Okay, so the students is a list of all records. This is a list object of all records. So take one record at a time, and all the instance variables of the student object, student dot name, city, address and pin code are displayed in one row. One student object, the data is displayed in one row, such like all the rows will be iterated and it will complete a table of all the records in the student table. So this is the explanation of show all.html. So this students SQLite database is already present in our application folder. I am now showing you the SQLite database using the SQLite Studio. And in this students database there is a table called as students, and this is the structure of the student. Remember, we have given this structure in our students class. This is a primary key and these are the four fields: name, city, address and pin code. So db.string is corresponding to or is being mapped to the varchar size. This was the size that was given. Okay. And of which this student ID is the primary key that also we had given in our declaration of the students class, right? And right now these four records are already present in this table. Now our intention is to just to verify whatever operations that we perform on this SQLite database through our Python code, whether they are, you can just verify that those operations are exactly stored and reflected in this SQLite Studio. Okay, so just to show you that if the record is added, that should be visible here, and if the records are listed, those are listed, the list exactly should match with this list. That is the intention of showing you the SQLite Studio. Now let us start our Flask application app.py from the command line. The server is running. There are some warnings with relation to the configuration of this Flask SQL Alchemy, but then you can ignore. The server is running. So what we have to do now, to go to the browser and give this URL localhost 5000 /. So I enter this URL. It is giving the present list of records, and it is also giving me a link to add student. So it will take me to localhost 5000 new. So if I click on this new, there is a form. Fill this form. Something like this, and then submit. There you see the list is now updated. The fifth record is added. Record is successfully. This is the message that was flashed. So if I click on this add student again, this will be again there. Without entering anything, I just press submit. It will prompt me, please enter all the fields. So all the operations are now verified with the help of this. Let me go back to this SQL Studio and see whether the newly added record is appearing in that or not. So this is again the SQL Studio interface, students database, students table. The fifth record added is being displayed here. So our insert operation is successful, and the list is also properly being displayed on the browser with the help of all this we have done with the help of the Flask SQL Alchemy extension.